Lesson 1-4, solving absolute value equations. The absolute value of a number is the distance a number is from 0. We use the two parallel vertical bars for the symbol. And since distances are positive, the absolute value of a number is always positive. So here's an example of an absolute value equation. The absolute value of x equals 5. You need to find the value of x that works. And in this case, there's actually two of them. Negative 5 works because the absolute value of negative 5 equals 5. And positive 5 also works because the absolute value of positive 5 equals 5. And so sometimes with these equations, you are going to end up with two solutions. Let's try evaluating an absolute value expression. So 1.4 plus the absolute value of 5y minus 7. And we know that the y value up here is negative 3. Okay, that's given to us. So let's plug in negative 3 for y and see what our answer is. 1.4 plus the absolute value of 5 times negative 3 minus 7. Now the absolute value bars, you have to think of them as a grouping symbol. So following the order of operations, I have to evaluate inside the absolute value bars first. So I'm going to leave this 1.4 kind of hang out in front. And now inside the absolute value bars, I've got 5 times negative 3, that's negative 15 minus 7. Okay, and I'm still not done. Now I need to simplify negative 15 minus 7. So again, 1.4 plus negative 15 minus 7 is negative 22, so we've got the absolute value of negative 22. Okay, the absolute value of negative 22. We know that that's positive 22, so now I'm going to take 1.4 plus 22, and my answer is 23.4. Okay, so the thing you need to remember is always simplify the inside of your absolute value bars first. Once you get down to that number, then you can take the absolute value. All right, let's try an equation. Okay, so we learned a couple slides ago that sometimes absolute value equations have two solutions. The reason is, in this case here, the absolute value of x minus 18 equaling 5, there's two possibilities, right? We could have the absolute value of negative 5 equaling 5, or we could have the absolute value of positive 5 equaling 5. So you need to set up two cases anytime you're solving an absolute value equation. Here's case 1. X minus 18 could equal 5, because when we take the absolute value of 5, we'll get 5. Case 2, x minus 18 could equal negative 5. Because x minus 18 inside those absolute value bars, if x minus 18 equals negative 5, you're also going to get positive 5 for an answer. Okay, so let's solve each case here and see what our two solutions are. So I'm going to add 18 to positive 5. And in case 1, x equals 23. Okay, over in case 2, we said that x minus 18 could equal negative 5. So I'm going to add 18 to negative 5. And x is equal to positive 13. Okay, so our solutions in this case are both positive. Let's check them to see if they work. Let me switch pen colors here for the check. Okay, so we got two solutions when we did all of our work, but we're not guaranteed that they both are solutions. So we have to check them in the original equation. So going back up to the original problem, the absolute value of x minus 18, let's check 23 for x. Does it work? In other words, does it give us 5? All right, so 23 minus 18 is 5. Oh, I'm switching colors again. And the absolute value of 5 is 5. So 5 equals 5, the first solution checks. So we can put a big box around x equals 23. That one works. Let's try x equals 13. Into the original equation. So the absolute value of 13 minus 18, does that equal 5? 13 minus 18 is negative 5, so we have the absolute value of negative 5. Does it give us 5? Yeah, the absolute value of negative 5 is positive 5, so 5 equals 5. And the second solution also checks. So we've got two solutions here that work, 23 and 13. Let's try this one. Okay, so this time there's a negative 2 outside of the absolute value bar, so it's negative 2 times the absolute value of 3a minus 2, and that equals 6. So this means times. Now you want the absolute value part by itself, all alone, and so if you ever have terms outside of it, you have to cancel those out. It's illegal here to distribute. That doesn't work. Some students try to do that, but these are absolute value bars. They're not parentheses, and so we can't use the distributive property. So to cancel out negative 2, the opposite of multiplying is dividing. So if I divide both sides by negative 2, these over here will cancel out, and I get the absolute value of 3a minus 2 equals 6 over negative 2 is negative 3. Okay, now at this point you could continue to solve. You could set up case 1 and case 2. However, there's a problem with this particular equation. We're saying that the absolute value of something over here is equal to a negative number. And we just went over the definition. We know that by definition, you cannot take an absolute value and get a negative number because absolute values are always positive. So this equation is actually false. It will never happen. It's impossible because an absolute value can't equal a negative number. And so if you run into this situation, you'll just have to write no solution. Or you can always make the symbol for empty set. Okay, so no solution for this one. Okay, let's try one like this. You can see that we've got the absolute value of x plus 6 equals, and then on the right side we have more than one term, 3x minus 2. The absolute value symbol is by itself, so we're ready to set up case 1 and case 2. Okay, so case 1, the absolute value of, sorry, I don't want the absolute value there. When you set up your case 1 and case 2, you're not using absolute value symbols anymore. Okay, so x plus 6 could equal positive 3x minus 2, basically the original. And then in case 2, this is our negative case. X plus 6 could equal the opposite of 3x minus 2. And the opposite, or the negative, would be negative 3x plus 2, okay? So both signs have to change. It becomes negative 3x and a positive 2. If you have more than one term or more than one number, you have to switch the symbol on both of those for case 2. Okay, notice that the x plus 6 is the same in both equations. So now we have to solve. All right, I'm going to start with case 1. I'm going to start by subtracting x on both sides. These cancel out and I get 6 equals 3x minus x is 2x minus 2. Then I'm going to add 2 to both sides. 6 plus 2 is 8. And on the right side, negative 2 plus 2 is 0, and so I'm left with 2x. To solve for x, let's divide both sides by 2. 8 divided by 2 is 4, and so I get x equals 4. We'll check that later. Let's go over and see what the solution is for case 2. This time I'm going to start by adding 3x on both sides. X plus 3x is 4x. 4x plus 6 equals, these are canceling out here, and I just have 2 left on the right side. Let's subtract 6 on both sides. 4x now equals negative 4. And divide both sides by 4 to get x equals negative 1. Negative 4 over positive 4, x equals negative 1. We are not guaranteed that these two are actually solutions to the equation. So you go through all this work of solving both cases, case 1 and case 2, but now you have to check your solution. Okay, so I'm going to check in green here. You go up back to the original equation up here, and you plug in your solutions. I'm going to start with x equals 4. I need to check that the absolute value of 4 plus 6 is equal to 3 times 4 minus 2. Okay, so the absolute value of 4 plus 6, that's the absolute value of 10. And on the right side, 3 times 4 is 12, so I've got 12 minus 2. Okay, what do we have here? The absolute value of 10 is 10, and 12 minus 2 is 10. So this one works. The equation is true when x equals 4. That's a solution. Okay, let's try x equals -1 up into the original equation, the original form of the problem. So I've got the absolute value of -1 plus 6. Is it equal to 3 times -1 minus 2? Okay, so the absolute value of -1 plus 6, that's the absolute value of 5. And then on the right side, 3 times -1, that's -3 minus 2. Well, the absolute value of 5 is 5. But on the right side, -3 minus 2 is -5. And so here's a situation where you plug in your value and it does not work. 5 does not equal -5. That tells you that x cannot be -1. And so for this equation, we only have one solution, x equals 4. I've got one more equation for you. It's a little more difficult, so let's work through this one together. 2 times the absolute value of x plus 1 minus x equals 3x minus 4. We have to start by isolating the absolute value sign. So I have to get the absolute value of x plus 1 by itself. So let's start by adding x to the other side. And we get 2 times the absolute value of x plus 1 equals 3x plus 1x gives me 4x minus 4. Okay, now I still have to get rid of the 2 that's hanging out in front. Remember that you do not distribute it, you divide both sides by 2. So those cancel out. And on the right side, I need to divide everything by 2. All right, so now we finally have the absolute value of x plus 1 by itself on the left side there. On the right side, when you divide this whole side by 2, it means you have to take both terms divided by 2. So 4x divided by 2 gives you 2x, minus 4 divided by 2 gives you 2. So both things we have to divide by 2. And now we're ready to set up case 1 and case 2. So we had to do this original work first. Now we're ready for the second part of the problem. So case 1, basically the positive case is the same equation without the absolute value sign. So x plus 1 equals 2x minus 2. Case 2 is the negative case. X plus 1 stays the same. You need to reverse the right side of the equation. So it becomes -2x plus 2. I reverse both of these terms here. Okay, now we solve. So subtract x on both sides in this first case. 1 equals 2x minus x is x minus 2. Now let's add 2 to both sides, and we get x equals 3. We're going to check that later to see that it works. Over in case 2, I'm solving again for x. I'm going to start by adding 2x. Anytime I've got a negative here, it's always easiest to add on both sides. X plus 2x is 3x. So 3x plus 1 equals, these cancel out and I just have 2. Now I'm going to subtract 1 on both sides. 3x equals 1. Divide both sides by 3. And we get x equals 1/3. Okay? I have both cases solved, but I have to check now. So that's a critical part of your steps here, your problem solving. We need to check our solution. So when you check, you're checking back up into the original form of the equation. So I'm going to start with 2 times the absolute value of, my x value here is 3, so 3 plus 1 minus 3, does it equal 3 times my x value is 3 minus 4. I'll try to switch back to red here quick. Okay, so what I have now is 2 times the absolute value of 3 plus 1 is 4. So 2 times the absolute value of 4 minus 3 equals, on the right side, 3 times 3 is 9 minus 4. Well, let's do a couple steps in one here. 2 times, this is 4, 2 times 4 is 8, 8 minus 3 is 5. And on the right side, 9 minus 4 is 5. And so this solution works. This one checks. X equals 3. Let's try x equals 1/3. Let's see if that one will give us a good solution. Back up into the original equation. Now I'm going to replace x with 1/3. So 2 times the absolute value of 1/3 plus 1 minus 1/3 does it equal 3 times 1/3 minus 4. Okay, well, in the absolute value signs here, I've got 1/3 plus 1, that's 1 and 1/3. So I've got 2 times the absolute value of 1 and 1/3. In other words, I'm going to switch it to an improper fraction. 1 and 1/3 is 4/3. Then we're subtracting 1/3. And then on the right side, 3 times 1/3. These are reciprocal, so I get 1 when I multiply them. And I've got 1 minus 4. Okay, now 2 times the absolute value of 4/3. That's 2 times 4/3. I get 8/3. You just have to multiply the top numbers there. Minus 1/3. And on the right side, I have 1 minus 4. That's -3. Now, I hope that you guys will agree with me that 8/3 minus 1/3, that's 7/3. And 7/3 does not give you -3. So this is not true. That means that x is not equal to 1/3. And the only solution that works in this equation is x equals 3, the one that we got over in case 1. Okay, now it's your turn to practice. I've got 2 problems for you. Please have these completed for tomorrow in class, and we'll go over them to see if you understand.